Hello, welcome to this first video in a series of videos about how to solve more difficult geometry problems. I've got an example of one of these problems here. So it's the kind of question where your usual geometry techniques won't actually work. So in this one I've got a triangle where this side and this side are equal. This is 80 degrees. This is 20 and this is x, and we want to solve for x. I'd encourage you to pause this video now and actually have a go at the question before watching the rest. Okay, so hopefully you've had a go at this question. What I'm going to do is I'm going to go through all the different kinds of problem solving techniques, or at least give you a basic overview of the problem solving techniques that you can use to solve these kinds of problems. So as you can see, this unit of work is called Constructions in Triangles, and this is just the introduction lesson to that. I've got quite a few more advanced lessons coming soon, hopefully. So the basics is you want to do some constructions inside this triangle to create more information that you can use. And what sort of things should we construct? Well, let's take a look. So generally, the things I want to construct are one of these 6 things that you can see here. And let's have a quick look at each of them. So if I have some triangle like this with an unknown value of x in it, if I was to construct a congruent triangle with a known value, I could use that to solve x. If I can construct an equilateral triangle, well, I immediately know all of the angles in here are 60. I can fill out 3 more angles and I'll get some further information. The next one, it's one you might not see as often, but if you can construct a right angle triangle with one side equal to a, whatever a is, and one side equal to 2a, then we can actually work out all the angles inside it. And we know for a fact that if I have a right angle triangle of this format, then this angle in here is going to be 30 and this angle here is going to be 60. Why is that, you might ask? Well, the reason is if I was to extend this out and draw another congruent triangle here, this is A, this is 2a here, you can see what our triangle actually is just half an equilateral triangle where that's 60, that's 30, and that's 90 because I've just drawn on a perpendicular bisector here. So triangles with the ratio 1, 2, 2, 4, 3, 6, and so on, you can immediately work out their angles. Okay, the next thing you can construct, if you can construct a isosceles triangle with a right angle in it, you can immediately fill in all these angles as well. You can go, okay, well, I know this is 45 and this is 45 because the total is 180 and you've already used 90 there. And those two have to be equal. So if you can ever actually construct any one of these 4 kinds of shapes, you can immediately create 3 new angles and then use those to add a lot more information to your problem solving. However, most of the time you can't just construct a equilateral triangle, a 30, 60, 90 triangle, or a 45, 45, 90 triangle, or some congruent triangle, which immediately give you what you want. There's often a lot of intermediate steps. So what we often do is we construct a series of isosceles triangles and we build multiple isosceles triangles on top of each other until we can get one of these other figures here, or until we can just solve the problem with isosceles triangles. Now, if we've got a triangle with 2 angles here that are known, then we also know these 2 sides are the same. Well, if I've got a triangle with 2 sides that are known, then I immediately know these two angles are the same. And constructing isosceles triangles is probably going to be the main technique you use for a lot of these questions. The other thing you can construct sometimes is a right angle triangle, and the good thing about a right angle triangle is if you find out this angle, you automatically know this one here. And usually the ways that you construct a right angle triangle is you start off with an isosceles triangle and you draw the perpendicular bisector down there, and then you can get a right angle triangle and hopefully get some more information out of it. But you're probably thinking, well, okay, if I look at this question here, what am I going to do? Draw a bunch of random isosceles triangles, a bunch of random congruent triangles, and so equilateral triangles all over it, and so on and so on. How's that actually going to help me find x? So what we're going to do now is we're going to look at some techniques which we can use to construct these kinds of figures in a way that they're actually useful for us for problem solving. Okay, so the first technique that we're going to use is something called drawing the Servian. Now, you might not have seen this word Servian before, but it's actually quite simple. A Servian just refers to if I have some triangle like this one here. So here's a triangle like this one here. A Servian is any line joining the vertex to the opposite segment. So there you go. That's a red Servian internally. And let's just draw one more. And I'm going to now put an extended line on here. So let's just extend it all the way out to here. So it's a projected line. And here's my Servian here externally reaching that line there, and I'll just need to extend that line a little bit more. Okay, so let's do a bit of practice drawing the Servian. So the first exercise I have you for drawing the Servian is I want you to draw an internal Servian, which is a line on the inside, to split this triangle into two smaller triangles where the left one is going to be isosceles. So pause the video and have a go at that. Okay, so I hope you've actually drawn this out and really had a go at it. You'll learn a lot more if you're actually doing these exercises along with me. But let's take a go. I'm going to draw an internal Servian, and I'm going to construct my Servian along here, and I'm going to make it such that this is 4 theta. Okay, so I've chosen to construct the line like this. I now know that this and this are equal because my base angles are equal. But I know another little bit of information as well, and this Servian always gives me another little bit of information. It's going to tell me that this angle up here is theta. The reason is 3 theta plus theta equals to 4 theta, the external angle of a triangle. Or I could of course say, or the exterior angle of a triangle. This is of course 180 minus 4 theta, angle sum, and this is 180 minus 180 minus 4 theta, which cancels out the 4 theta, but it's much easier just to do it immediately as an exterior angle of a triangle. Okay, you ready for your next Servian question? Here we go. Example 2. Draw an internal Servian to make the right inner triangle isosceles. So if we look back at our previous question, we could see we made our left inner triangle here isosceles. Now I want the right inner triangle to be isosceles, okay? So let's see if we can do that. Now let's draw my Servian on. And the first thing I'm going to think about is, well, I'm going to have to make it look a bit like this, and I'm going to have to say, let's make this one here is going to have to be, you can possibly work it out, this one here is going to have to be 6 theta, and you can see I didn't really draw it to scale very well, so let's actually just improve my scale just a little bit. Of course my real triangle isn't to scale, so it's not going to be perfect, but let's make this 6 theta. And you're thinking, well, Why is this 6 theta? That's because 3 theta plus this one has to equal to 6 theta. So of course we have a 3 theta up here, and now you can see we've made our right inner triangle, which I've shaded in, an isosceles triangle where that side equals to that side. Okay, ready for your next Servian example. Write this one out and do have a go at it first. So what we're going to try to do is we're going to make it so that we're going to draw an internal Servian, and we're going to make a triangle that's congruent to this one here, which is going to have a 4 theta in it and a 2 theta. Alright, so let's do it. So let's first of all draw my internal Servian, and down it's going to go, and let's just maybe try and do it a little bit to scale. Oh, that's the same line. That one will do. So I now know, okay, well, I'm going to make this one here is going to be equal to 6 theta, and you can possibly see why I want this one to be 6 theta, because 4 theta plus this one here has to equal to 6 theta, so of course I'm going to get my 2 theta up here, and there we go. I've made two congruent triangles by the angle side test. So I've got this one here and this one here are congruent. Okay, so what I did was I constructed an internal congruent triangle that was congruent to this given triangle. Okay, so that's a technique we're going to be using quite a bit. Okay, next one. We're going to draw an external Servian now. That means we're going to put the Servian on the outside. So draw an external Servian to make a big isosceles triangle, and this one's actually a nice easy one. So what we're going to do is we're going to just extend this side out here for however long it needs to extend out for. So we're extending this one out here, and our external Servian is going to look like this, and I'm going to construct that so that that's 2 theta. That's equal to that, and let's just fill it in here like so, and let's see if we can get our bonus angle. We know we've got a 2 theta here, a 5 theta here, so what do you think goes up here? And hopefully you realized it's a 3 theta, and the reason for that is because 2 theta plus 3 theta equals to 5 theta, and that's the exterior angle. Okay, one more Servian question. We're going to draw an external Servian to make a triangle congruent with this. So I've got a 3 theta and a 2 theta and some side next to the 2 theta, but we've got a triangle with a 2 theta and a 5 theta here. So notice I can't actually draw an internal Servian to make this, because just imagine if I did, right? I put it in here like this. Well, this angle has to be bigger than 5 theta because it's steeper. So we know it has to be an external Servian, and we just extend this line out here like so, however long it needs to be extended out, and then I just extend this out like, oh, that's not a very good line. I just extend this out like this, such that this is 3 theta, and you can see now I've made a angle here, and I've got a 2 theta and a 3 theta and an equal side, a 2 theta and a 3 theta and an equal side. And let's just double check they're really congruent. I want this marked side to be opposite my 3 theta, and the marked side is opposite the 3 theta, so we do have a congruent triangle. Now let's just fill in our bonus angle. Hopefully you're getting used to it now. This is 3 theta, this is 5 theta, 3 theta plus this equals to 5 theta for the exterior angle, so hopefully you know that it's a 2 theta. And there you go, that's technique 1, or one of the 3 techniques, and that's drawing a Servian. Okay guys, keep watching for the second technique. Okay, so our second technique it's a much easier one actually. It's called completing the scalene triangle, a bit like completing the square, only completing the triangle. Well, actually, really nothing like completing the square. So let's take a look. Let's say I've got a scalene triangle like this, and all I'm going to do is I'm going to pick this side to be the side I want to make my isosceles triangle equal to, and I complete the scalene triangle by turning it into an isosceles triangle. And you can see this, oops, let's just draw that one on again, and you can see this red line here. I make it such that these two sides, such that this side and this side are equal to each other. And that's actually almost it for the technique. In a few future lessons you're going to see some more advanced applications of it, but it's basically just turning a scalene triangle into an isosceles triangle. You may have thought, well, this is in fact exactly the same as drawing a Servian, because look, I've just extended out this side here and then drawn a Servian along here. The reason I've got it as a separate technique is because when I did my Servians, and let's just go back to a Servian, I just extended this line out as long as it needed to go, and then I fixed the Servian with a particular angle. When I did this one here, I take a partially completed side and I extend it for a very particular amount of distance such that it's equal to the other side. So I just thought I'd separate out those two techniques. A very useful thing with this, of course, is after you've drawn an isosceles triangle, what you can always do is put in a perpendicular bisector, and you've created two congruent right angle triangles, which are very helpful for problem solving, which you'll see in some future videos on this. Okay, and the third of 3 techniques is building a triangle from the side. This one will have a few little subparts on it, so let's take a look. What we're going to be doing is part A, 3A. We're going to be building an equilateral triangle. So what this means is we pick one side in an existing triangle to be a side of our equilateral triangle, and then I build an equilateral triangle off of it. So I'm going to go, okay, this side here, before I do that, let's look at the question. I want you to construct an equilateral triangle such that there are going to be 3 30-degree angles in our diagram. Now the first thing you should probably notice here is that you saw this earlier on in the lesson. If this is A, this is 2A, you know that this is going to be 60 and this is going to be 30. So what we're going to do is we're going to pick one of these 3 sides, 1, 2, 3, to draw our equilateral triangle off, such that we're going to wind up with 3 30-degree angles in our final diagram. So pause the video, see if you can do that first, and do actually practice drawing it out with a pen and paper. Okay, so I'm assuming you've had a go. So what I'm going to do is I'm going to pick this side here, and I'm going to draw an equilateral triangle with this side here as one of the sides. So here it is, 1 and 2. Hopefully that's a good enough equilateral triangle. There it is. And I know that, well, that's 60 degrees. That's 60 degrees by definition of an equilateral triangle. So that's 30 degrees because 30 and 60 is 90. And I know that this is 30 degrees as well because 30 and 30 is 60. And we've completed our task. we've drawn it an equilateral triangle, and we've made 3 30-degree angles, which would hopefully be useful if we were solving a problem where we needed to find maybe a triangle that was congruent to some other one that had a 30 degrees in it. Okay, let's look at the next part of building our triangles. So in this one, we're going to be constructing an isosceles triangle, and we're going to build one equal side of an isosceles triangle. So what that means is, let me show you here. If I have a random triangle like this, what I do is I nominate one of the sides to be an equal side, and then I build an isosceles triangle off it like that. Or I build an isosceles triangle off this side like this, or I build an isosceles triangle off this side like that, choosing it to be the same length, and I can make the angle in here whatever I want. So the goal is now to see if you can pick a side to build an isosceles triangle from, where and you're going to try to create two pairs of congruent side triangles which all have a side equal to the marked side. So we're going to try and just build an isosceles triangle and wind up with two pairs, four congruent triangles that all have some side equal to this side here. So please pause the video and do really have a go at it, okay? Okay, I'm assuming you've had a go at it, so here's what I'm going to do. I'm going to pick this side here to be the side that I build off, and I'm going to now build off here. So I'm going to pick something that's the same length as this, like here. So here it is, and I'm going to make this the same length as this, and you can see now I'm going to join this up down to here like this, and hopefully my diagram's to scale enough. And remember, I said I can choose this angle, okay? So I'm going to make this angle such that it's equal to 20 degrees. Now the reason I've made that this is equal to 20 degrees is because this is an isosceles triangle. This bisects the angle at the top of the isosceles triangle, so we know that it's actually a perpendicular bisector, right? Because of course this triangle here and this triangle here are congruent, SAS. So now I'm just going to add on a side here like this. But I know that this side, and this side are equal because these two triangles are going to have to be congruent as well, because of course any line from a corner to a perpendicular bisector of an isosceles triangle is equal to the other one. And let's have a look at my angles I've made, my triangles. So I've got this red one here is congruent to this one here, and this one here is congruent to this one here. And notice that they actually all have this side here in common. So there you go, two pairs of congruent triangles with this side here, or a side of this length, equal to all of them. Okay, so let's now move on to our next one, and it's going to be the second way of building an isosceles triangle. So we saw the first way of building an isosceles triangle, which was to pick one side and draw an equal side off it. Now we're going to do the second way, and the second way is, I'll give you a little sneak peek here if you like. We're going to start off with just a random side, and then we build two equal sides off it like that. So it's like that and like that. And then rather than taking this one here and building an equal side to this, we build two equal sides off of here, and this original side is the odd one out. Alright, so let's now do that. Let's build this shape here. So what have we got? Draw an isosceles triangle to form the the following figure. And you'll learn a bit later on, this is actually a special figure in this more advanced problem solving as well. So let's do it. First of all, we know that, and please do have a go at it before you just watch me do it. That's 7 theta, and that's 5 theta. Let's just move the 7 theta and 5 theta outside so they're out of our way. 7 theta and 5 theta. Now what I want to do is I want to make an isosceles triangle, so I'm going to draw it from here to here. This one's not going to be very to scale, and that's okay, it doesn't have to be that to scale. You get the idea. So this isosceles triangle is going to be here and here. And what do I need to make this equal to? 3 theta and 3 theta, and then of course you've just got 4 theta there and 2 theta here, and your leftover shape is just this one here. So there it is, that concave quadrilateral. Okay, the final part of technique 3 is to build a, didn't want to use that one, is to build a congruent triangle from the side. So what we've got here is we've got this triangle, and I want a triangle that's congruent to this red one, okay? And I'm going to use this side here. So this is fairly straightforward. What I do is, and have a go at it first before you just watch me do it, is I'm going to go, okay, let's let this be 90 minus theta, and I think I need to write it there. If I write it too far to the left, it slows down the program I'm using. So this is 90 minus theta, and I'm just going to mark this with some double marks. So what I'm going to do is I'm going to build a angle, a line down here, such that this is double marked, and let's use red to do it actually so it stands out. So I'm going to build a line down here like this, such that these two are the same length, and also such that this is 90 minus theta, and then I'm just going to join this up like this. Now if we look at our two triangles, this one and the one I've constructed, side 90 minus theta angle, side 90 minus theta side, and I've constructed, of course, a second congruent triangle to this one here below it. Notice it's not actually congruent to this one here because that's got a theta and not a 90 minus theta between the two sides. And as a bonus observation here, you may or may not have noticed, but that's the right angle because you've got theta and 90 minus theta. So guys, that's in fact it. Those are the only techniques you need to be able to solve all these problems. There's only 3 of them. Draw a Servian on the inside and outside, complete a scalene triangle, or build a triangle off the side, and you can either build a equilateral triangle, a isosceles triangle adding 1 equal side, an isosceles triangle adding 2 equal sides, or you can custom build a triangle that's congruent to another one, and that's it. Those are all the constructions. Okay, so now let's have a look at how we can use these constructions. Okay, so here's our original question, and what we're going to do is we're going to be using these techniques to see if we can solve it, and we'll only use these techniques along with our basic geometry. So my techniques are, I want to build these kinds of shapes here that you've seen, and I've got 3 techniques: building Servians, completing scalene triangles, and building triangles off the side. So I start off with my 20 degrees, and I feel like, well, it'd be good if I can build other things with 20 degrees in them, right? Because then I can hopefully go back and use either some more isosceles triangles with 2 lots of 20 degrees in them, Or maybe if I'm especially lucky, I can even make a congruent triangle to x, to something with x in it, and then solve it. So I'm going to start off with technique 3, I think the first part of technique 3, which was building off the side, and I'm going to build an equilateral triangle off the side as my first go. So there we go. That's possibly an, what do we think? Maybe that's a decent equilateral triangle. And then we'll get another one here, and that's an equilateral triangle. There you go. Hopefully that looks like a good enough equilateral triangle. And because it's equilateral, this equals to this equals to this. Okay, so I know that I've made a 60-degree angle here by definition. So I know that that must be 20 degrees. And now I've just got 2 points that I can join up, so let's join them together. And I've got this point here and this point here. And remember, I also said I'm always looking for isosceles triangles. And let me just I just realized I've used a single line to indicate this one and this one. So let me just put a double line to indicate these ones here. And can you guys see another line that has that double line in it? Let's take a look. What about this line here? This is 80, this is 20, so by definition this is 80, and I got ahead of us and actually broke it up as 20 and 60, but if this is 80, this is 20, we know this has to be 80 because the whole thing adds to 180, so I know that also this one here is got that same double line. But now let's take a look at this triangle here. Let's take a look at this triangle here. This line and this line are the same. So this is an isosceles triangle. But I also know that, well, this has to be 40 degrees, and I hope you can see the reason, because that whole thing's 60, because that's part of the equilateral triangle that we sketched. And let's take a look at what we've got now. Well, if I know this is 40, and this is why isosceles triangles are great, I know that has to be 70, and I know that this has to be 70, because 70 and 70 and 40 is 180, and these two base angles have to be the same. But remember, I also know this is 60 from the equilateral triangle I built. So we go here, and I'm just going to make this as 60, and this is 10, because I can see the whole thing here is equal to 70. But let's take a look at what I've built now. I've got a 20 degrees, a single line side, and a double line side, a 20 degrees, a single line side, and a double line side. So I've got these two congruent triangles, which I'll shade in green. Here you go, these two congruent triangles, which I've shaded in green. But I also know that, well, this part here is 150, 80, and 70. So I now know this has to be 150 because it's a matching angle in a congruent triangles, those two green shaded ones. So therefore I know that x equals to 30 degrees, and you can see how powerful those techniques are. I just built a triangle off the side, and then the congruent triangles came right out and we solved it. Okay, so you guys also might be thinking, well, sure, is that really a good technique? I mean, how do we know which technique to use when? So let's now try and solve this triangle using a slightly different technique. Okay, so I've got the exact same question. I've got my same triangle, 80, 20, By angle sum, this is 80, so I know this big triangle here is isosceles, and we're going to solve for x. But this time, I'll say I won't construct that external equilateral triangle, even though it was a nice solution. I'll do it in a slightly more cumbersome way to show you that it still works, and we're going to solve it by constructing Servians. Alright, so here's what I'm going to do. I'm going to start off by constructing a Servian down here. And remember, what I want to do with my Servians, I want to make isosceles triangles, equilateral triangles, or triangles that are congruent to something that I've already got. And I can't really make any equilateral triangles yet, so I'm going to make an isosceles triangle. So I'm going to start my Servian up here, and I'm going to construct it down to about here like this. I'm aiming to make an isosceles triangle like this. So here we go, and that'll probably do. So what isosceles triangle am I going to make? I'm going to construct it such that this angle here is 40 degrees. And there's a few reasons I like that. One, as you'll see in a future video, if you've got a triangle where one base angle is double the other, you can actually do some extra special constructions with it. But the reason I like 40 degrees here as well is 20 plus 20 equals to 40. So I've very nicely built an isosceles triangle because I know I've got this part here, and I'm just going to draw the 20 up here like this for the time being. I may rub it out if I need that space later on, but that's 20. And of course I know that now this is equal because, and when I say this is equal, I've used this line here, but that was actually a really silly thing to do because this and this aren't equal. In fact, the lines that are equal, let me try to do a different notation, is this line, let's give it a squiggle, is equal to this line. So you can see I've built this, and this is an isosceles triangle. And I hope you guys can also observe here that this equals to 60 degrees. So now I'm going to make another Servian, okay? I'm going to get this inner triangle here, and I'm going to build a second Servian, and I'm going to use my Servian to make an isosceles triangle, which in this case will also be an equilateral triangle. So let's draw it on, and I'm going to draw it up to about here. Does that look equilateral to you? Maybe about there? Alright, that looks equilateral enough. So I've now constructed my Servian such that this is 60 degrees. I've still got my straight line drawing tool on here. So this is 60 degrees. And if this and this is 60 degrees, this must be 60 degrees, and this are the same. And while I'm at it, that's 20 degrees. So you can see what I've done is I've just built an equilateral triangle like this with a Servian, and an isosceles triangle like this with a Servian, and an isosceles triangle like this with a Servian. And now I've got this little triangle here left over. But let's actually just take a look at something very interesting that I notice. This side and this side are the same. This side here and this side here are the same. But this side's equal to the little dash, and this side's equal to the little dash. So that must mean that I've got two more equal sides now, and I'm just going to use a green double dash to indicate them. This side and this side have to be the same, and hopefully that makes sense because these green double dashes are both equal to a blue squiggle minus a red dash, and a blue squiggle minus a dash there. Okay, so now I've got this, I can see, well, hang on a second, two equal sides, I certainly know what that's a part of. That's a part of an isosceles triangle, and remember I did say constructing isosceles triangles is the absolute best thing we can do, or it's one of the best ways to solve this. So I'm going to draw an isosceles triangle down to here like this. And let's fill in the angles of our isosceles triangle. So I know that this is equal to 140 degrees, and that should be obvious because it's the angle sum on a straight line. But this is isosceles, so this and this is equal, so that's 20 degrees and that's 20 degrees. And then I'm going to go, well, hang on a second, this is 20 degrees and this is 20 degrees. That means this is an isosceles triangle. See, there it is. This is an isosceles triangle. So now we've got another side which is the same, and we've got this side here that's the same. And what's so interesting about that is we now know, okay, this is an isosceles triangle, but look at this. This side here and this side here are the same, so we've got another isosceles triangle here. So let's do an angle sum now. I've got 20 here, 40 here, so I must have, I think I'm going to have 120 here. Oh, I will have 120 because look, 60 and an angle on a straight line, obviously 120. So I know this is now 120, but now I've got angles at a point. Look, 60, 120, and 20, add all those together, and those are 200. But I've got 360 here, so that must mean I've got 160 left over up here. But I've got my isosceles triangle here. 1, 2, 3. This is 160. This little bit here and this little bit here are the same, so we fill those in, and we've got a 10 and a 10. But I've drawn over this a bit, but you can see my x was here, and that 20 and that 10 are my x, so my x equals to 30 degrees. So there you go, guys. You can see you can use these different techniques in multiple different ways to solve questions that are seemingly impossible. Okay, guys, thanks very much. That's it for the introduction to problem solving with constructions in triangles.